this lesson, we're going to talk about distance, rate, and time problems. So to start out, we need to remember the formula. Distance is equal to rate times time. For example, if you're driving 30 miles per hour, and you drive that speed for 4 hours, you're going to drive 120 miles. We can use this formula also to figure out time if we know distance and rate. So to get time by itself, you would just divide distance by rate. So time is equal to distance divided by rate. And if we wanted to get rate by itself, we would divide by the time. So rate is equal to distance divided by time. These are three ways of looking at the same equation. This is all based on distance being equal to rate times time. In the worksheet we're going to look at, all of the problems are set up using a table of some format. You've got two people or two things happening, and you have a distance, a rate, and a time for each of them. And for each one of these, we're going to use some form of this formula right here. So let's start out with number one. It says the Princess cruise ship left San Francisco and traveled south. So sometimes it's helpful to say we have the Princess cruise ship and she left and she headed south. The Queen Maria cruise ship left 1 hour later at a speed of 30 miles per hour. So we're going to go ahead and put that right in the table, 30 miles per hour for the Queen Maria. And it says she caught up with the Princess cruise ship. So she must have also left here from San Francisco. Here's the Queen Maria, and she's leaving. Now what we want to know is the cruise ship's average speed. So that's right here. That's what we're looking for. We're looking for her speed. And then let's look at time. We said the Princess cruise ship left San Francisco and traveled south. The Queen Maria cruise ship left 1 hour later, and it took it 9 hours to catch up. So the Queen Maria traveled for 9 hours, and the Princess cruise ship had already been traveling an hour, so it traveled for a total of 10 hours. So we can plug in 10 hours for the Princess cruise ship and 9 hours for the Queen Maria. Then we need to look at distance. Well, they both left from San Francisco, and eventually the Queen Maria catches up to the Princess cruise ship. So what we know about the distance, while we don't know what it exactly is, we know that their distances are equal. So we know if distance is equal to rate times time, then the rate times time of the first ship has to equal the rate times the time of the second ship. So we're going to say 10 times R for the Princess cruise ship has to be equal to 30 times 9. 10R equals 270. So R is equal to 27. Now what was R? If we go back and look, R was the rate of the Princess, and that's what the question asked. What was the cruise ship's speed? And so it was 27 miles per hour. Okay, let's take a look at another one. The Prince Walter ship left a port traveling north 4 hours before Queen Sadie's ship left and headed south. So this one's a little bit different, right? We have both of them leaving from the same place, but one is leaving and going north, and one is leaving and going south. So we have the Prince Walter, and we have the Queen Sadie. And we know that Prince Walter left 4 hours before Queen Sadie. Okay, so he's been traveling for 4 hours more than how long she's been traveling. If we continue looking at time, we'll see that Queen Sadie's ship was traveling for 2 hours when the two ships were 2 miles apart. So if the Queen Sadie had been traveling for 2 hours, that means that the Prince Walter had been traveling for a total of 6 hours. So we can put both of those pieces of information into our table. We also know that Queen Sadie was going 15 miles per hour faster than the Prince Walter. So Prince Walter, we're going to give him a W, and Queen Sadie was going W plus 15. Now we need to look at the distance. The only thing it tells us about distance is that the ships were 230 miles apart. So from here to here is 230 miles. So that's a total of the Prince Walter's distance plus the Queen Sadie's distance. So Prince Walter's distance plus Queen Sadie's distance has to equal 230 miles. So we're going to do rate times time for the Prince Walter, rate times time for the Queen Sadie. So 6W plus 2 times W plus 15 has to equal 230. So sometimes you'll see problems where the distances are equal, like in the last one. Sometimes, like in this one, you'll see where the two distances have a sum. They add up to a greater distance. So now we're going to go ahead and solve this algebraically for Prince Walter's speed. 130, so subtract off the 30. 8W equals 200, so W equals 25 miles per hour. And if we go back to the question, what was the average speed he was traveling at? That's the answer to our question. So the Prince Walter's speed was 25 miles per hour. Okay, in this next one that's on your worksheet, there were a few mistakes in the typing. So I want you to go ahead and change the names in the table. You'll notice these are the same names as before. So cross out Prince Walter and change it to Prince David. And then our second ship is the Prince Albert, so PA, Prince David and Prince Albert. And this question says, how many hours did the Prince Albert ship travel? So we'll start out by fixing those typos. And now we can look at the information we've got. The Prince David ship headed south at an average speed of 20 miles per hour. Let me go ahead and put that in there. Later, Prince Albert traveled north with an average speed of 20 miles per hour. So they're going the same speed. And after the Prince David ship had traveled for 8 hours, the ships were 280 miles apart. So we know Prince David left first, and he traveled for 8 hours. So we can go ahead and put that in here. All we know about Prince Albert is that he left afterwards. So was he more than 8 hours? Was he less than 8 hours? Well, if he left after, he must have traveled for less than 8 hours. What we don't know is how much less. So we're going to do 8 minus t, and that t would be however long he waited before he left. Now we know that one of them headed south and one of them headed north, and then after that period of time they were 280 miles apart. So this is another one where they give us the total distance that the two boats traveled. So we're going to do Prince David's distance plus Prince Albert's distance is equal to the total distance. Well, the total distance is 280. And then to get Prince David's distance, we're going to do rate times time. So 20 times 8 is 160. Plus Prince Albert's, we need to do 20 times 8 minus t. Be careful there. Sometimes the parentheses throw people. Remember that you're going to need to distribute to both pieces. Now, as you start to solve this, you may notice that you end up with a negative. And a negative 40 over here. That's okay because the coefficient of t is also negative. So when we divide by that negative 20, our time is still going to end up being positive, which is good. So that means he must have waited 2 hours, because that's this number right here, is 2. But this asks how many hours did the Prince Albert travel? So it was 8 minus 2. So his actual time traveling was 6 hours. Okay, we're going to do one more just to practice setting this up. Anna took her scooter and headed to the beach, driving 20 miles per hour. Brianna left 2 hours later and also headed to the beach on her scooter, driving 20 miles per hour. How many hours did Anna drive before Brianna caught up with her? Well, let's talk about this. If Anna leaves and travels at 20 miles per hour, and Brianna waits and then leaves traveling the same speed, if they're both traveling the same speed, then one of them is never going to catch up to the other one. They're going to stay that same distance apart. So the answer to that one is just that she can't catch up. Sorry, one more. A jet took off for Toronto heading west at a speed of 405 miles per hour. Another jet left Toronto from the same airport sometime after, traveling at a speed of 486. 10 hours later, the second jet caught up with the first. On this one, I just want to practice setting up a problem. So we're not going to solve this one, we're just going to set it up. So the first jet was flying the speed of 405 miles per hour, and the second jet was traveling at a speed of 486. So what we know is the first jet was traveling for a while. 10 hours after this, it was traveling for a while. First jet took off and it was traveling at that speed. 10 hours after the second one left, it caught up. So we know that the second jet flew for 10 hours. How far did the first jet fly? Well, we're not sure. All we know is it was 10 hours plus some amount, because we know that it was traveling longer. And then you could set up, you know that their distances are equal, so we know rate times time was equal to rate times time. Now, we've done several problems where one thing is trying to catch up with another, or maybe they're flying until they reach a certain distance apart. But you'll notice in these problems as you begin to read them that a lot of them fly. Say a jet leaves Oklahoma City and it flies to Dallas, and then it flies back. These are round trip problems. When you're looking at the round trip problems, you want to think about how far is it, how do these two distances compare? The distance from Oklahoma City to Dallas is the same as the distance from Dallas to Oklahoma City. So this is one where your distance 1 is going to be set equal to your distance 2. The flight there has to be equal to the flight back as far as distance goes. All right, and that's it.